All right, so it's 4.2 is the section we're covering right now. This section's about proportions. We talked about ratios in 4.1, and 4.2 is going to take ratios and take two of them and set them equal to each other. And so we're going to decide if two things that are given really are equal, so we're going to say yes or no. And then they're going to give us two proportions where something is missing, and they're going to have us solve a proportion. So we're just getting into that solving algebraic portion of this class. So here's our first example. It says, is 3 to 8 equal to 2 to 5? So we're looking, these problems are different than anything else because they have an equal sign between them, not an add, subtract, multiply, or divide. Okay, so we're going to treat them differently than we have anything else in the past. These are also ratios, okay, because any proportion that we're doing is a ratio. So these are not fractions. You will never get a whole number out of these. You will never turn them into mixed numbers. So we're asking, are they equal? Well, the way that we check to see if they're equal is we multiply from the bottom to the top on both sides, and we write the answers and we compare both those answers. So what I need to do is I multiply 8 times 2 and I get 16. I multiply 5 times 3 and I get 15. And so I'm comparing 15 and 16. Are they equal? Not which one's bigger, but they're asking, are they equal? Because that equal sign is right here. And so the answer is no. Final answer. Okay, let's look at another one to try to make this make more sense for us. This next one is 4 to 6 is equal to 8 to 12. So the question is these two given ratios, are they equal? So I told you we multiply from the bottom to the top and then the bottom to the top. So 4 times 12 gives me 48, and 6 times 8 gives me 48. They both match, so yes, they are equal. Okay. All right, so let's move on. Now we're going to talk about word problems that they give us. We're going to set the ratios up ourselves and then decide, are they equal? It's possible that we will have something that's missing on some of them, and we may have to solve them. But the first one is Mary worked for 6 hours and she built 11 toys. Okay, Sue worked for 2 hours and built 3 toys. So I have two ratios, right? And they're very clearly separated. One's Sue, one's Mary. And so we're going to set these up and we're going to compare them. So if we're talking about Mary, we have 6 hours and we have 11 toys. Is it equal to Sue, who worked 2 hours and built 3 toys? So we're asking ourselves a yes or no question for this one. So let's see. If we multiply in the diagonals, I get 22, and I multiply in this diagonal, and I get what? Well, 3 times 6 gives me 18. So are these going to be the same? Are they building at the same rate of time or speed? And so 18 is not equal to 22, and so this is a no. Okay, so then the other question comes up, well, who built the fastest? Well, remember in 4.1, when we were trying to find out that unit rate for each person, like how fast you built things, we actually put the time or the units of, remember it was the ounces of peanut butter? We put the money on top and the ounces of peanut butter on the bottom because we knew that we wanted it per ounce as our final answer. For this one, we don't want per toy, we want per hour. We want to know how many toys per hour they can make. And so we're going to have to switch these around, and we're going to talk about Mary first. And we're going to say right now she builds 11 toys in 6 hours. Okay? We want to know how many she can build in 1 hour. So to get 1 hour on the bottom, I would need to divide the bottom by 6 to get that to become a 1. What I did on the bottom, I need to do the top, and so 11 divided by 6 gives me 1.8 toys. Remember I told you that it was okay that it wasn't a whole number that came out on top if we were talking about unit rates, and so I have 1.8 toys per hour. So this is Mary's unit rate. Now I need to find out what Sue's unit rate is. And so I need to take the number of toys she has over what I want my denominator or my bottom to be, and that's the unit rate. So I want it to be toys per hour, not hours per toy. So toys per hours sounds a little better, so I put 2 on the bottom. For a unit rate, I want 1 hour on the bottom, so how do I get that? I divide both of them, top and bottom, by 2. And so 3 divided by 2 gives me 1.5 toys per hour. So I'm asking you another question. We first of all asked if they were the same rate, and we said no. The second question is, who builds faster? So is 1.8 toys per hour or 1.5 toys per hour faster? Well, the bigger decimal is Mary, and so she builds more faster. So Mary builds toys faster than Sue. All right, so this one is no word problem. It's actually just a proportion set up, and I want you to see that they have an X in here. This X does not mean multiply. This X means it's something I don't know. So that's why those of you that are using X's for multiply, I don't really like that. I suggest you quit using that. We're using the dot or parentheses from now on, because we've introduced the X, and the X means it's a variable. Variables represent something that we do not know. And so for this problem, for us to be able to solve, we're using something called the cross product. Product meaning multiply. So we are going to multiply, and I do want to point out that this equal sign is our divider sign, okay? It keeps things separate. So what do I mean? I want to multiply over here, and everything that ends up on the right stays on the right of the equal sign, everything that ends up on the left stays on the left. So what I'm multiplying and going to the right side is going to be 3 times 5, and on the left side I have x times 15. Does everybody see that? I ended up on the right side, so everything in this line ended up over here. And I ended up over here on this side, so everything in that line ended up on this side. Brought my equal sign down straight in the middle. So I'm going to simplify, I'm going to multiply. 15 times x gives me 15x. No more dot, they're touching, number comes first, letter goes second. And 3 times 5 gives me 15. For me to solve and find out what x is, I need x all by itself. So I look at right here, and I see 15 and x are touching, which means that they were multiplied together, okay? To undo or get them apart and leave x all by itself, I need to do the opposite of multiply, which is divide. And I divide by whatever it is that I want to go away from my x. So I divided by 15. Whatever I did to one side of the equal sign, I have to do to the other side to keep this a balanced problem. So on the left side I have the x, in the middle I have the equal sign, and then on the right side I have 15 divided by 15, which gives me 1. So my answer for this is actually x equals 1, or the ratio of 1 to 3, because I'm filling it in over here, right? So depending on what they ask you in the instructions, you may put one of those two things right there. But x is actually only equal to 1. All right, let's try another one. I have n to 4 is equal to 25 to 20. So I want you to see that n is also a variable. It represents a number that we do not know. Okay, letters that we will not use would be 0 because it looks like, or O that looks like a 0, so we won't use that number. And later when you get into harder algebra, we won't use other letters because they mean something else. So for example, we don't use I very often because I actually represents imaginary numbers. And we'll talk about that at the very end of your pre-college algebra 2 class. All right, so from here, we are using cross product, and I'm going to draw my x here, and I will multiply 4 times 25 on the right side, and I will multiply n times 20 on the left side. Why am I going to the right? Because bottom to top I ended up on the right, and so everything over here stays here. All right, so I multiply and I get 20n, because they touch, get rid of the dot, and the number comes first, then the letter. And 4 times 25 means I have 4 quarters, which gives me 100 or $1, right? However you're looking at that. All right, I need n all by itself, so I need to do the opposite of what I see here. So what I see here is multiplication between 20 and n. To undo multiplication, I will divide by whatever it is that I want to go away from my n, and that's divide by 20. I do the same thing on the other side to keep this a balanced equation. I end up with n on the left side, equal sign in the middle, and then the answer of 100 divided by 20 is going to give me n equals 5 as a final answer. Okay. Let's try another one. We've got 6x over 6 is equal to 150 to 6. All right. At first glance, there's something that's kind of hard and misleading about the 6's. You think that they have a common denominator and you should do something crazy and different like you did in Unit 2. I'm sorry, in Unit 3. But you're not going to, because you see an equal sign in the middle, so you know that these are two ratios set equal, so this is actually a proportion. And so for us to solve this, we will multiply in the diagonals. So I multiply 6 times 150 and it goes on the right side. And the other diagonal, I multiply 6 times 6x and it goes on the left side. So when I multiply these two, sorry, I probably should have done this before. And so I'm going to put that in my calculator and I'm multiplying 6 times 150 and I get 900 on the right side. And 6 times 6x gives me 36x on the left. Okay. How do I get x all by itself? I do the opposite of what I see, and I see a multiply because they're touching. So I'm going to do division, and I divide by whatever it is I want to go away from my x. So I divide by 36 on both sides to keep this a balanced equation. So 900 divided by 36 in my calculator, I literally put in 900 divide 36. And I get the answer of x equals 25. Final answer. Okay, we're going to try one that has kind of a cooking word problem. So I'm going to type out this little word problem here for you. All right, so you need 2 cups of sugar for 10 biscuits. Oopsie. Okay, and how many cups of sugar do you need for 30 biscuits? All right, so we're setting up a proportion. So the first one I know what it is. It's 2 cups for 10 biscuits. Okay, is equal to, I don't know how many cups of sugar for 30 biscuits. So I don't really need the cups of sugar and biscuits labels for these, but what I wanted you to see is if I put cups of sugar on top, I had to put cups of sugar on top. And if I put number of biscuits on the bottom, I also had to put the biscuits on the bottom. The labels have to be both the top and both the bottom. They have to match across the top and across the bottom, because if you mix them up and put cup of sugar on the top over here and biscuits on the bottom and then switch it, biscuits on top, sugar on the bottom, you're never going to get the right answer, okay? So we have this proportion. So here you can actually ignore or actually get rid of these labels after you've got it set up correctly. So we're going to solve this. And so on the right side I have 10 times x, and on the left side I have 2 times 30. So I end up with 60 is equal to 10x. All right, I need x to be all by itself, okay? And so for me to do that, I need to divide or do the opposite of what I have. And I'm going to divide by 10 because that's what I want to go away from x. A lot of students make a mistake and they divide both sides by 60. I don't need to divide by 60. I need to divide by whatever number is touching my letter. Okay, that moves it to the other side to leave the letter all by itself. So I do the same thing on both sides, and 60 divided by 10 gives me x equals 6. I know what you're thinking, that's actually 6 equals x, but if you rewrite it, it's the same. As long as 6 is still positive over here and x is still positive over here, it's the same thing. You can write it either direction. Okay. All right, the last two are not terrible, but I am going to draw a couple of pictures to help them make sense. Okay, whether you know it or not, these are two proportions. They are everything that you had in a problem like this. they just look a little bit different. Okay, so let's look at this again. What I actually see, and I'm going to color this one in. This is your small triangle, okay? And then I'm going to color it in the other way on this one. And this is, oops, sorry, that's supposed to be red. This is your big triangle. Do you see how they kind of overlap? Okay, so we're going to talk about two of these separately. And I'm going to try to drag the color off of these so I can talk about what we just saw. Okay, so I'm going to rewrite these, and we're going to talk about the little triangle to look like this, okay? And we're going to label what they are. Where did I get these? From here and from here, because I talk about that little triangle. For the big triangle, 30 and 50, right? 50's here, 30's here. It talks about those two different pieces. The good thing is that we have two sides, right? And we have two bases. So I changed them colors because I want you to see when we set up these proportions, you want to make sure that the reds are both on top and the blacks are both on bottom, or both of the blacks are on top and both of the reds are on the bottom. They have to be the same units, just like we did in this one. We wanted both of the cups of sugar on top and both of the number of biscuits on bottom. We had to keep them the same, matching. Same thing here. So on top, I'm going to do the red side, which is 20 and 50. Everybody see where I got these from? Here and here. And on the bottom, I want you to see that that's where my X is for the little triangle and 30 for the big triangle. Okay? So now I'm solving a problem just like I have been doing. I want to multiply to the right, multiply to the left, leave my equal sign in the middle. So I'm multiplying X times 50, and I have 20 times 30. And so 20 times 30 gives me 600 is equal to 50x. I'm going to divide both sides by 50 because that's what I want to go away from my x. And when I divide 600 divided by 50, I find x equals 12, or 12 equals x. Remember, both of them are the same as long as they are both positives. Okay, we're going to do one more of this because I feel like my students on their test really struggle with this, and so I really want to be clear on how to make sure we set this up and how the numbers get set up in their correct places. So last one of these. Okay, if you want to pause this for just a second to try to see if you can set this up on your own, now would be the time to do it. Okay, so now I'm going to draw both of the triangles. Here's the small triangle and here's the big triangle, and I'm going to redraw them both. Okay, here's your small triangle, here's your big triangle. The big triangle has a side of 60 and a base of 50. The small triangle has a base of x and a side of 10. So we're going to set these up. 10 over x is equal to 60 over 50. Please notice that I went side over base, side over base. You have to keep it consistent in that same order. Could you have written it like this? Absolutely, as long as both of your sides are on top or on bottom, and both of your bases are on top or bottom. They have to stay the same, okay? But you're going to get the same answer either way. So we're going to multiply in the diagonal, and solve. So 5 times 10 and 60 times x. I get 50 is equal to 60x. I divide by 60 because that's what I want to go away from my x. So I put 50 in my calculator, I divide it by 60, and I get x equals 8.33. So 8.33 is the measurement of the base of the small triangle. All right, so that finishes out our section for 4.2. Make sure that you finish your TOYOs, and I would suggest watching the review for this to make sure you prepare for your test.